So as I said, the subject is a combination of theory and numericals. The numericals or all the terms which we are going to study in this particular chapter, maybe electric field, magnetic field, or a potential, or the flux density, magnetic, electric flux density, all these are vectors. And therefore, students should know the vectors thoroughly, how to write down the vectors, what are the operations which can be done on the vectors, and what is the result of those operations. So that is why this particular next 1 hour is going to be just understanding the vectors. For non-diploma students, you already have done it maybe in your HSC or maybe in the first year. But for diploma students, you need to pay attention in this prerequisite. This PPT also will be uploaded on the Google Classroom so that you can refer it anytime. Because all the problems that we are going to solve ahead in this particular subject will be dealing with vectors. Okay. First we will first we will understand what do you mean by vector, or what is you remember the difference between scalar and vector? Anyone? Now let's keep it interactive because I am not asking you something which is very difficult. I am asking you something that you already know. So do you remember what is the difference between scalar and yes, Ananda, tell me.
Scalar is it has magnitude,
yes,
and vector has magnitude and direction both.
Very good. Okay. So scalar is a quantity which is described by only magnitude, and vector is something which is described by magnitude and direction. Okay. So if I ask you weight, what is this quantity? Is it a scalar or a vector?
Scalar.
Scalar. Okay. So weight is having only a magnitude. But if I ask you force, then
Vector.
Is a vector.
Ma'am,
So you
have
have
you changed the screen? Ma'am, can I say?
Yes, बोलो बेटा क्या हुआ? Change the screen.
मतलब मैम आप थर्ड स्लाइड पढ़ा रहे हो और आप फर्स्ट स्लाइड पे ही
Yes. I will just okay. So if you say vectors, if you say the force, then it not only has magnitude, but also in which direction that force is being applied. That is also important. So therefore, I am happy that all of you remember the difference between scalar and the vector. Okay. So how do you represent the vector? So the length of the vector, okay, the length of the line represents the magnitude. Okay, so bigger is the length, more is the magnitude. Okay, so if I draw a vector, maybe a diagram, then what does that diagram depict? It depicts that the length of the line represents the magnitude and the arrow indicates the direction. Okay, so your vector is going to have a tail and the head. Okay, so the head has an arrow and the tail doesn't have anything. Okay, just a simple line. Okay, so the magnitude and direction of the vector is clearly labeled. Okay, so therefore the length of the line represents the magnitude and the arrow indicates the direction. Okay, so please remember all vectors have a head and a tail. Okay, so let us understand how to write down a vector. Okay, so in this particular subject, we are going to deal with two coordinate systems. Okay, the first coordinate system, which you already know, that is a rectangular coordinate system in which we have three axes, x, y, and z. One more coordinate system we have, or rather than that, we have two more coordinate systems. The second one is cylindrical coordinate system, and the third one is a spherical coordinate systems. But the spherical coordinate system will be taught to you in the next subject in this domain, that is in the subject of antenna. which may be in the next semester. So that time, the spherical coordinate system will be introduced to you. For this subject, we are going to study or we are going to solve problems in rectangular coordinate systems and cylindrical coordinate system. So we'll be understanding the cylindrical coordinate system also in this particular presentation at some later stage. So let us first understand how to write down a vector in the rectangular coordinate system. So in rectangular coordinate system, we represent any point in X, Y, and Z. Okay. So for time being, let us assume only two-dimensional rectangular system wherein.
अर्चना मैम,
Yes, sir.
आप मतलब फर्स्ट स्लाइड्स पे ही पूरा डिस्कशन होगा या फिर मतलब
मैं
आगे?
आगे गई हूँ सर.
नो, इट्स नॉट नहीं.
नो मैम, आपका स्क्रीन वही पे दिखा रहा है अभी भी.
बस स्लाइड पे ही है मैम.
ओके, मैं फिर से शेयर करती हूँ. अभी now can you see a vector?
मैम जस्ट वेट अ मिनट, स्टिल इट इज लोडिंग.
No. Okay, your screen share has been paused. Pause क्यों हो गया?
फर्स्ट स्क्रीन, सॉरी फर्स्ट स्लाइड.
Now?
इट्स फर्स्ट स्लाइड ओनली.
ऐसे क्यों हो रहा है? मैं तो थॉट्स और यहाँ पे दिखा रहा है. Your screen is sharing.
मैम आप अगर एक पर्टिकुलर टैब सिलेक्ट करके शेयर कर रहे हो ना तो वो नहीं होगा.
Now?
हाँ,
मैम इट इज विजिबल.
Okay. Okay, so.
Miss, can you please repeat from start?
Okay. So we were talking about the vectors, and since we are going to solve the problems on problems which are based on the vectors, because all the quantities in this subject, whether you talk about electric field, magnetic field, flux density, or force, they all are vectors. So therefore, we are going to solve the problem considering them as a vectors. Okay, so maybe you have done Coulomb's law in your HSC or maybe first year, and you have just calculated the force, using the formula Q1, Q2 upon 4 pi r epsilon 0 r square. So here this r, that is a distance between the two charges. It is basically, maybe you have calculated that the force is say 5 Newton. But here we are not going to calculate the magnitude of that force. We are going to calculate the this force as a vector. Okay, so therefore you should know the vectors thoroughly. So I was talking about that this vector is basically represented by an arrow. The length of the arrow represents the magnitude, and the direction of the vector is shown by the arrow. Okay, so wherever the arrow is pointed, that indicates the direction. Okay, so I was talking about the three coordinate systems. Okay, first one is rectangular, second one is cylindrical, and spherical. Spherical in the next semesters. This semester, in this subject, only two coordinate systems we are going to understand: rectangular and cylindrical. In rectangular coordinate system, we represent any point by x, y, and z. Okay. So right now we are just considering the two-dimensional rectangular system. So there are these 2 points P and Q, and which are which are having coordinates as x1, y1 and x2, y2. So if you have these 2 points, okay, and suppose that there is a vector which is from the initial point P to final point Q, then how do we write down this vector? Okay, very important. Students ये भी नहीं लिख पाते हैं. So understand how to write down a vector. It is very simple. So this is the magnitude of the length, that is the length of the line. Okay, so how do you write down this vector? So see, this vector is from P to Q. Okay, so any vector is represented by PQ and you have to write down a straight line above, indicates it is a vector. Okay, so it is PQ bar. Okay, so PQ bar represents that it is a vector. And how do you write down this vector? It is x2 minus x1. So x2 is the x coordinate of the end point or the terminal point, and x1 is the x coordinate of the starting point or the initial point. So x2 minus x1, a bar x. Okay, so a bar x is a unit vector along the x direction. Okay, so you can say this is x2 minus x1 will have some value. Let us say 7. So 7x a bar x. Okay, plus y2 minus y1 a bar y. If you have z coordinate also, then suppose the terminal point has z coordinate z2 and the initial point has z coordinate as z1, then इसके आगे क्या लिखोगे? z2 minus z1 a bar z. Okay, so this PQ bar, for example, can be written as 7 a bar x plus 5 a bar y plus 2 a bar z. Okay, so ये जो 7, 5, 2 ये जो है, these are the coefficients along x, y and z direction. So this is how you are going to write down the vectors in the rectangular coordinate systems. Okay.
Miss, are you sharing the second screen? Miss,
I am sharing the vector वाला screen. Still the third slide पे हूँ मैं. कौन सा slide दिख रहा है आप लोगों को? Third slide दिख रहा है ना?
Yes, Miss.
PQ bar दिख रहा है ना?
Yes, Miss. Yes, Miss.
Okay. Okay. Now I am going ahead. Okay. So अभी वेक्टर कैसे लिख दिया आपको समझ में आया. अभी उस वेक्टर का वैल्यू, दैट इज द मैग्नीट्यूड ऑफ द वेक्टर, वो कैसे कैलकुलेट करता है. Again, I am maintaining the same points x1, y1 and x2, y2, and this is how you are going to write down you are going to calculate the magnitude. So अगर आपका force आ गया, suppose F is equal to 5 a bar x plus 7 a bar x plus 5 a bar y plus 2 a bar z. अगर ये आपका force आ गया तो आपको this is the component of this force along x, y and z direction. So आपको अगर ये force का total value निकालना है, then you should know how to calculate the magnitude of this vector. So magnitude of this vector, इसलिए वो PQ bar जो है वो mod में लिखा है. Okay, so mod of PQ bar indicates the magnitude of this vector, which is calculated by under root of x2 minus x1 square. x2 minus x1 square क्या था? It was the coefficient of along the x direction. y2 minus y1 was coefficient along the y direction. Similarly, अगर z भी है तो z2 minus z1 will be coefficient along the z direction. Okay, so under root में अभी suppose जो मैंने पहले example लिया था, it was 7 a bar x plus 5 a bar y plus 2 a bar z. तो अभी मैं उसका magnitude कैसे करूँगी? Calculate 7 square plus 5 square plus 2 square. Okay, इसको under root उसका ये जो addition होगा इसको square root उसका निकालना है. That will be the magnitude of that particular force or that particular vector. So this is how we are going to calculate the magnitude of the vector. Okay, please remember this. Okay. अभी ये जो magnitude हो गया और वेक्टर कैसे लिखने का ये भी हो गया और magnitude भी हो गया. Okay. Now we will calculate or now we will write down the unit vector. How to calculate the unit vector? Unit vector means ये जो PQ bar जो vector आ गया ना, okay, इसका unit vector कैसे निकालते हैं? So unit vector is always written with letter A. सो आपको दिख रहा है ए बार, यूनिट वेक्टर कौन से वेक्टर का निकाल रहे हैं हम लोग, PQ, इसलिए ए लिखा है और उसको सफिक्स में PQ लिखा है. सो A PQ bar is a unit vector. Okay, so how to write down the unit vector? Unit vector is calculated by vector divided by its magnitude. Okay, so vector divided by its magnitude is called as unit vector. So therefore A bar PQ is going to be PQ bar divided by mod of PQ bar. Okay, so we already know this. ये हमने पहले ही 2 स्टेप में निकाला है. Okay, so it is, I have just divided what we have calculated in the first, in the last slides. Okay, so this unit vector PQ bar is PQ bar divided by its magnitude. Okay, now this unit vector has, if you want to calculate unit vector having the same direction as that of given vector, we find out the magnitude of vector divided by its divide the vector by that value. That's what I talked to you earlier. अभी let us calculate the unit vector. Okay, तो ये vector आपको दिया हुआ है in general 3a bar x plus 4a bar y. Okay, what is the mod? What is the mod of w? Can someone tell me? Mod means इसका magnitude आप कैसे calculate करोगे? Someone please tell me the answer.
Under root of 9ax square.
It is 3 square
5.
plus 4 square, that is 9 plus 16, that is 25. इसका under root लेना, that is 5. Okay, so we can say that the magnitude of this w is going to be 5. Okay, I hope it is clear. अभी इसका मुझे unit vector निकालना है. Okay, unit vector of vector w. Okay, so how will I calculate a bar w is going to be 3 divided by 5. 5 क्या है? 5 is the magnitude और जो 3 है that is a vector. Okay, so it is vector divided by its magnitude. Okay, so 3 by 5 a bar x minus को है actually. Okay, okay, so यहाँ पे minus होना चाहिए. ठीक है. तो यहाँ पे शायद minus होना चाहिए. should be minus. Okay, so इसलिए यहाँ पे minus sign आया है. Okay, so when you do this, यहाँ पे square जब भी करते हो तभी ये positive ही होगा. Okay, so 3 by 5 a bar x minus 4 by 5 a bar y. Now ये जो unit vector है इसका अगर आप magnitude calculate करोगे then you will find that the magnitude का value आता है 1. Okay, let's check whether the unit vector has magnitude 1. So अगर ये जो unit vector is a bar w. a bar w का अगर मैं unit vector का magnitude calculate करती हूँ, so it will be always 1 irrespective of whichever vector you write down, the magnitude of unit vector will be always 1. Okay, now suppose initial point जो है आपका, अगर initial point origin होता है, so if your initial point okay, if the initial point becomes origin, that is 0 0, and the terminal point suppose is any x1 y1 x2 y2 or xy in general, then that vector is called as a position vector. Okay, please remember this. Now the next is product of two vectors. Okay, so अगर आप दो vectors का product लेते हो तो कैसे calculate करते हो? So here I have considered two vectors v and w. So v is a1i. अभी देखो maths में आप लोग ijk use करते थे, right? Okay, maths में you have studied vectors and you used to write down ijk as a unit vectors along x, y, and z direction. Okay, but in this subject, okay, since there are two cylindrical system, rectangular or cylindrical, आपको ijk नहीं use करना है. For rectangular cylindrical, for rectangular system, this I will be replaced by a bar x, this j will be replaced by a bar y, and k will be replaced by a bar z. Okay, please remember this while solving the numericals. Okay, students problem solve करने के time भी ijk use करते हैं. Okay, that is not right. So here I have used IJK so that you can correlate with respect to your mathematics subject. So V is A1 I plus B1 J and W is A2 I plus B2 J. So अगर मैं इसका मुझे और मैंने भी A B और जो भी है उसका कुछ वैल्यू कंसिडर किया है. So V is so अगर मुझे ये मल्टीप्लाई करना है that is V मल्टीप्लिकेशन अगर मुझे यहाँ पे करना है V और W का अगर मल्टीप्लिकेशन करना है V and W are the two vectors, then it's going to be the product of their x coefficient plus product of their b coefficient. अगर k का भी कुछ है तो वो आगे आएगा. Okay, वो प्लस करके जो भी k का कोएफिशिएंट रहेगा that will be added. Same we are going to apply here. Okay, so in this particular example I have taken some numerical values. So V and W is written there and you are going to find out the dot product of V and W. Okay, so it's going to be okay. So अगर आप आपको मल्टीप्लाई करना है दो वेक्टर्स, then you are just going to multiply the x coefficient or in this case the I coefficient. Okay, so -2 और 4 को मल्टीप्लाई किया that is the coefficient of I और बाद में उसको ऐड किया है with the coefficient of J. अगर Z है अगर K है तो उसके बाद यहाँ पे कुछ प्लस साइन करके और कुछ वैल्यू ऐड है. So if I calculate this will be minus two vectors is going to be a scalar value. As you can see, it is -3. -3 has only magnitude; it doesn't have any direction. So please remember the product of two vectors. Okay, so product of two vectors is always a scalar. So this product is called as dot product, and please remember dot product of two vectors is going to be scalar value. So where this dot product is used, what is the application of this dot product? So when you take a dot product of two vectors, it is used in calculation of angle between the two vectors. So U and V are the two vectors and the angle between these two vectors is theta. Then U and V are suppose non-zero vectors and the angle between them is theta. Then the theta value can be calculated by a dot product. So remember this formula. Cos theta is going to be dot product of U and V divided by multiplication of their individual magnitudes. Okay. So U bar लिखा है multiply by V bar, right? So this is the application of dot product, that is calculation of angle between the two vectors. So if these are my two vectors V and W, then I can calculate the angle between these two vectors by simple taking the dot product. So पहले dot product लेते हैं. This is my formula. Cos theta is equal to V dot W divided by mod of V into mod of W. Okay, so V dot W 18 कैसे आ गया? 3 multiplied by 6. Okay, as I told you that dot product में क्या करते हैं, जो भी I का कोएफिशिएंट है उसको मल्टीप्लाई करते हैं. So 3 multiplied by 6 is going to be 18. इसलिए यहाँ पे 18 आया है. और यहाँ पे 2 multiplied by 4 that is 8. इसलिए यहाँ पे 8 आया है. उसके बाद ये क्या है √13. ये कैसे आ गया? दिस इज द mod of v. इसका मॉड कैसे आएगा? 9 plus 4. ओके, सो 9 plus 4 is 30 √13. और इसका मैग्नीट्यूड क्या आएगा w का? 36 plus 25. 36 plus 16. Okay, so 36 plus 16 is 52. That is √52. So I can always calculate the cos theta here. स्प्रेडशीट बंद हो गया, एक मिनट। दिख रहा है स्क्रीन?
Yes.
sir.
So cos theta is going to be 26 divided by under root of 676, and it's going to be 1. So cos theta is 1. So what is the value of theta? It is going to be 0. That means angle between V and W is going to be 0. So when the angle between two vectors are going to be 0, they are called as parallel. Right? So when the two vectors or the two lines are parallel to each other, the angle between them is 0. That means they will never intersect each other. So again, this can be useful in find out whether the angles are parallel or they are perpendicular. So when the vectors are perpendicular, they are called as orthogonal. So this property is called as orthogonality. So दो vectors अगर orthogonal है, angle between them will be 90 and cos 90 will be 0. So whenever you get cos 90 as 0, it should strike to your mind that since the angle between the two vectors are cosine of the angle between the two vectors are going to be 0, two vectors are going to be perpendicular to each other. That's what this is written. So this is V and this is W. So the vectors are in the same direction, so they are called as parallel. Okay. So this is also the vectors are parallel. So if the angle between the vectors are going to be 90, okay, then cos theta is going to be 0. Okay. So cos theta 0 आ गया, मतलब the dot product is going to be 0. Cos 90 is 0. तो ये division 0 आ गया, मतलब the numerator is 0. So numerator 0 मतलब u dot v is going to be 0. So whenever two vectors are going to be perpendicular to each other, the dot product is always 0. So we can just verify this. So I have another example. V and W are vectors are given, whether you have to find out whether they are orthogonal or not. So अगर आपको orthogonal को है कि नहीं वो find out करना है, simply take a dot product. और अगर dot product 0 आ गया तो angle is 90. So if you take the dot product, you will find that it is 90. So 4 multiplied by 2, that is 8, and minus 1 multiplied by 8, that is minus 8. So 8 minus 8 is going to be 0. That means the dot product of V and W is 0. That means they are at 90 degree. Okay. Or perpendicular to each other, or they are orthogonal, I can say. So orthogonality of the two vectors can be found out by dot product. So this is another example of, this is another application of the dot product. Okay. Yes, students, does it make sense? Is it okay? Should I go ahead? Diploma students, can you speak up? Are you getting it?
Yes, miss.
Yes, miss. थोड़ा थोड़ा समझ रहे हैं.
Okay, very good. So what is needed is you need some practice, okay, of writing the vectors and calculating the magnitude, writing the unit vectors, and getting the dot product कैसे calculate. इसका थोड़ा सा practice करो, so that तभी हम actual problem solving चालू करेंगे, तभी you should be clear in your mind. So this PPT will be uploaded in the Google Classroom. So just go through it once again. Okay. The another multiplication of vectors is a cross product. So either you can take a dot product or you can take a cross product. Please remember, cross product of two vectors is going to be a vector. जैसे dot product results into scalar, similarly dot product cross product results into vector. So cross product of two vectors कैसे निकालने हैं? So it is basically calculated by this particular determinant. So as you can see, first the first row here is the unit vector. So I, j, k के जगह अभी आप लिखोगे a bar x, a bar y and a bar z. Okay, this is with respect to your mathematics. With respect to this subject, as I said, ijk in the rectangular will be replaced by a bar x, a bar y and a bar z. 1 minute. सो ये कैलकुलेट कैसे करना है वो बता देती हूँ. Let's take an example. Okay, so A has these coordinates, coefficients 1, 3, and 4, and B has coordinate 2, 7, and -5. So let us calculate A bar cross B bar. Okay, so यहाँ पे IJK लिखा. So maybe you can write down A bar X. Okay, then you can write down A bar Y, and you will write down here A bar Z. Okay, 1, 3, and -4 is the coefficient of A vector. 2, 7, 4, -5 is the coefficient of B. Okay, अभी क्या करना है वो बता देते हैं. Okay, अभी क्या करना है? When you take अभी इसका रिजल्ट जो है that is going to be vector. Okay, so when you consider the first column, this 4 number will be in use. ये इनका multiplication होगा. Okay, when you consider the first column, this one. So 3 multiplied by -4, ये मैंने consider किया. When you consider the first column, when you consider the second column, that time 1, 2, 4, and -5 will be there to calculate determinant. And when you consider the third column, that time these 4 terms will be there. These 4 numbers will be there. 1, 2, 3, 7. Okay, so इसका 5. Okay, 3 multiplied by -5, that is -15, minus 7 into 4, that is -7 into 4 is 24. Similarly, यहाँ पे हमेशा माइनस साइन आती है. This all of you know, but still I am repeating. -5 into 1, -4 into 2. So -5 into 1 is -5, -4 into 2 is minus. Okay, यहाँ पे हमेशा माइनस साइन आती है, यहाँ पे हमेशा प्लस साइन आती है. Again 7 into 1, that is 7, -3 into 2, that is 6. Okay, so this becomes -43, and this becomes minus plus, that is +17, and this becomes 1. So coefficient of K is 1. So A bar cross B bar has resulted another vector which has, again this will be A bar X, okay, this will be A bar Y, and this will be A bar Z. Instead of X, Y, and Z, okay, instead of IJK, you will be using A bar X, A bar Y, and A bar Z. Okay, so the cross product of two vectors has resulted into another vector, right? So अभी ये जो क्रॉस प्रोडक्ट का जो अंदर वेक्टर आया है उसका मैग्नीट्यूड भी हम कैलकुलेट कर सकते हैं. Okay, that will be under root of 43 square plus 13 square plus 1 square. Okay, so please remember that the dot product of two vectors is a scalar value, but the cross product of two vectors is going to be a vector value. Let's go ahead. Okay, so the vector is completely determined by its magnitude and direction. So A bar cross B is going to be जैसे हमने डॉट प्रोडक्ट का फॉर्मूला देखा था वैसा ही क्रॉस प्रोडक्ट का फॉर्मूला क्या है, mod of A into mod of B into sine of angle between the two. So the orientation of this particular result of cross product is a vector. तो इस vector का जो orientation है that will be calculated by the right hand rule, and the length of this vector is calculated by another formula, that is, if you know the angle between these two vectors, then you can use this formula. If you don't know the angle between the two vectors, then you can use the previous formula, that is this one. Either you calculate the vector by this formula, और फिर बाद में इसका मैग्नीट्यूड कैलकुलेट करो, जैसे हम वेक्टर का मैग्नीट्यूड कैलकुलेट करते हैं, और अगर आपके पास उन दोनों के बीच का एंगल है, okay, that is this angle, then you can calculate the length of that vector by this formula also. There is two formulas for the cross product of two vectors, that is either this or the sine theta wala angle, that particular formula. So this particular slide shows the three most commonly used coordinate systems as I was talking about. So this is Cartesian, और इसको rectangular भी बोलते हैं. So we just solve some of the problems in the rectangular. So यहाँ पे तीन axis होता है, x, okay, y and z. Okay. In the cylindrical coordinate system, there are in the rectangular coordinate system, any point is written as x, y, and z. Okay. Similarly, in the cylindrical system, the point is written as r, then phi. अभी phi को मैं ऐसा लिख रही हूँ, phi, r, phi, and z. So these are the coordinates. So rectangular coordinate कैसे लिखते हैं, x, y, z से, और cylindrical coordinate कैसे लिखते हैं, r, phi और z. अभी ये r, phi, z क्या है वो आपको मैं बाद में बताती हूँ. Okay, so please remember, in cylindrical system, any point in the cylindrical system is going to be written as x, y, z. In the coordinate system, in the rectangular coordinate system, the point is written as x, y, z, and उसका unit vector होता है a bar x, a bar y, a bar z. Okay, so हम लोग वेक्टर कैसे लिखेंगे? वेक्टर लिखेंगे फॉर एग्जांपल 5 a bar x, okay, plus say 2 a bar y, say minus 3 a bar z. This is how you write down the vector in the cylindrical, in the Cartesian or the rectangular coordinate system. The same thing in the cylindrical system. Okay, यहाँ पे unit vectors are a bar r, a bar phi, okay, and a bar z. Okay, please remember यहाँ पे ना, जैसे ये जो x, y, z या फिर ये 5, 2, 3, okay, they are the planar values. All these are the planar values. And यहाँ पे जो cylindrical में ना ये जो phi है, that is angle. Okay, so therefore यहाँ पे जो vector लिखते हैं, that is a different. यहाँ पे जो a bar phi है, that is a basically the angle. Okay, so this is how you write down the vectors in the Cartesian and cylindrical system. Cylindrical का और detail में हम लोग आगे देखते हैं. Let us first understand some concepts in the rectangular systems.
Why are we adding A?
Huh? Yes.
Ma'am, why are we adding A?
Why are we?
Ma'am, why are we adding A?
I cannot hear you properly. This is how you write down
Yes,
a
ma'am.
vector.
Am I audible?
हाँ, बोलो.
Yes, ma'am. What is the significance of using A?
Significance of using cylindrical system.
No, ma'am. The
A. He's talking about A, AX, AY, AZ, right? Is it your doubt?
Yes, sir.
Okay.
देखो ये जो तीन these are the three angles. These are the three axes, right? A x, y and z. Okay, so
Archana
ये
ma'am.
जो point, हाँ sir.
Who was that person who was asking question?
What's your name?
Acha, Rohit na? Rohit, it's actually na, it's a then suffix x.
हाँ ये ऐसा है, मैं अभी ना वो लिख
तो
नहीं
हाँ
पा
यहाँ
रही
पे
हूँ।
लिखा नहीं है, इसके लिए ऐसा है.
suffix x और ये बार ऐसा लिखते हैं उसको.
So a is actually referred as unit vector,
Unit vector. This is
but
a bar
it is along the x-axis. That's why
y.
x.
और दूसरा है a bar.
So like we are mentioning the unit vector in terms of a to the suffix of x, y, and z.
Yes, because in Cartesian the axes are x, y, z. Okay, so these are the unit vectors along x, y, z. So x के along जो unit vector रहेगा, that is a bar x. Okay, this is a bar x. जो y के along रहेगा, that is a bar y. और जो z के along रहेगा, that is a bar z. तो ये यहाँ पे मैं suffix नहीं लिख पा रही हूँ, but actually आपको जो notebook में लिखना है वो ऐसे लिखना है. A bar x, a bar y, and a bar z. Okay, so 5 understood. So 5 a bar x is there. That means the its coefficient along x. Okay, coefficient along x is y 5, 2, and -3. किसी भी point का. Okay, so this is the point. Then इसका coefficient along x, y, and z. These are the coefficients which are written here. 5, 2, and -2. Okay. So similarly, a bar r, a bar 5. अब ये भी ऐसे लिखना है. A bar r. A bar 5 कैसे लिखेंगे? A 5 is like this. 5. Okay. And third one is a bar z. So r, phi, and z are the suffix, and a represent the unit vector. Okay. So in cylindrical system there is one angle. Okay, that is phi. In the spherical system there are two angles, that is theta and phi. So here here you represent any particular point as r. Theta and phi. So cylindrical system में दो एंगल आते हैं. Okay, so this is how you write down any point. Coordinates लिखते कैसे? So cylindrical में एक coordinate angle आता है. That is the middle one, that is phi. Okay. So let us go ahead with it. Okay, so let us understand Cartesian system in details. Any doubt? Any doubts?
Of unit vectors are independent of their position in Cartesian. वो जरा एक बार बताओ ना.
Unit vectors are the vectors along x, y, and z axis represented respectively. Hello? I didn't get your question properly.
उधर नोट लिखा है ना नीचे, वो ऐसा क्यों ऐसा इसलिए मतलब?
Are independent of their unit vectors are independent of their position because they will be always along the x-axis, irrespective of the vector. ये जो a bar x है ना, that will be always along x direction, positive x. A bar x जो unit vector है उसका direction कैसा होगा? It will be always along the positive x direction.
Yes, ma'am.
Okay. This will be always along y, positive y, and a bar z will be always along the positive z. Okay.
Yes, ma'am.
और cylindrical spherical system में angles of the unit vector depends on position because यहाँ पे angle आता है, यहाँ पे एक r आता है. जैसे मैं आपको ये बताऊंगी ना, जैसे cylindrical बताऊंगी ना, तभी मैं आपको बताऊंगी कि इसका position के ऊपर उसका direction depend कैसे होता है. Because when you say r, we are talking about the position of a रेडियस, ये तुम्हारा सिलेंडर है सपोज, इसमें सिलेंडर अभी मैं ड्रॉ नहीं कर पा रहा, एंड दिस इज योर आर. ओके, सो डिपेंडिंग ऑन द पॉइंट, ओके, डिपेंडिंग ऑन द पॉइंट आर विल बी वेरिंग, आर का डायरेक्शन रहेगा दैट विल बी वेरिंग. मतलब आर यहाँ पे भी जा सकता है, यहाँ पे भी जा सकता है, यहाँ पे भी जा सकता है ना, डिपेंडिंग ऑन द पॉइंट. बट यहाँ पे कैसा है, एक्स वाई जेड, एक्स वाई जेड, जेड विल बी ऑलवेज अलोंग द जेड एक्सिस. एक्स, अगर एक्स का एक्स पॉइंट किधर भी हो, लेकिन जो ए बार एक्स का होगा डायरेक्शन दैट विल बी ऑलवेज अलोंग द पॉजिटिव एक्स डायरेक्शन. लेकिन यहाँ पे कैसा है, सिलेंड्रिकल में, इट्स अ सिलेंड्रिकल ना, तो पूरा 360 डिग्री सिलेंड्रिकल होता है ना, तो पॉइंट जहां पे है, ओके, तो तुम्हारा पॉइंट कहाँ पे है. सो डिपेंडिंग ऑन द पोजिशन ऑफ द पॉइंट your a bar r will be along the radius, so it can be moving into the screen of the laptop or coming out of the laptop also. समझ में आ रहा है?
यस मैम.
जैसे अभी, जैसे मैं आपको, मैं अपना वीडियो चालू करती हूँ, देखो ये सिलेंडर है ना, कैन यू सी दिस सिलेंडर, ओके, तो मेरा ए बार आर यहाँ पे भी जा सकता है, मेरे पास भी आ सकता है, आपके पास भी जा सकता है. अगर मेरा पॉइंट कहाँ पे है उसके ऊपर डिपेंड रहेगा. इसलिए हम लोग बोलते हैं कि डायरेक्शन ऑफ यूनिट वेक्टर डिपेंड्स ऑन पोजीशन. तो जहां पे भी एंगल आता है ना, वहां पे इट ऑल डिपेंड्स ऑन, जैसे अभी स्फेरिकल में दिस थीटा इज द एंगल ऑफ अ कोन एंड आर इज द रेडियस ऑफ अ स्फीयर. तो स्फीयर अगर है तो जो ए बार आर है वो ऐसा भी जा सकता है, that is inside the laptop, or it can come to me also. So wherever you have angles in the coordinate systems, so at that time the position of point के ऊपर depend रहेगा कि unit vector का direction कैसा है. But always remember unit vector का direction will be always along the increasing value. Okay, जैसे अभी ये x है ना यहाँ पे, वैसे यहाँ पे -x भी होगा. Here there will be -x. This will be -x. A bar x will never be in this direction. A bar x will be always in the positive increasing value of x, y, z. In case of cylindrical, it will be always in the direction of increasing value of r, increasing value of theta, increasing value of z. माइनस r में कभी नहीं जाता है a bar r or a bar phi or a bar z. Okay, that is common with all the coordinate systems. Okay, but whenever you have angles, that is in cylindrical and spherical, then depending on the position, depending on the point, the direction of unit vector changes. Okay, I hope it is clear. जैसे आगे थोड़ा सा जाओगे तो जैसे प्रॉब्लम सॉल्व करेंगे ना,
यस मैम.
तभी आपको और थोड़ा क्लैरिटी आएगी. Okay, so let's go ahead and understand the cylindrical system. ये x, y, z कैसे आता है? So in Cartesian or cylindrical system, we have three axes x, y, and z. Okay, so this there are three planes basically. So which are the three planes? So as you can see, the first plane is the xy plane. Okay, the first plane is a xy plane. So xy plane कौन सा है? This plane. जैसे आप बैठे हो, वो जो आपका जो फ्लोर है, that is a xy plane. This is a xy plane. xy plane is a floor. So जो भी perpendicular जा रहा है axis, that is always a z axis. Okay, so xy plane को बोलते हैं z is equal to constant. So suppose ये xy plane है, okay, so यहाँ पे x z का वैल्यू constant रहेगा. So this value जो तुम बैठे हो, वो जो फ्लोर है उसका z का वैल्यू 0 है. Okay, you are sitting, all of you are sitting in your room, right? So जो भी आपका फ्लोर है, that is z is equal to 0. Okay, जो भी आपका सीलिंग है, जो सीलिंग दिख रहा है आपको सबको, तो सीलिंग जो फ्लोर है उससे परपेंडिकुलर सीलिंग है और पैरेलल सीलिंग है. ओके, सो जो भी आपका रूम का हाइट है, ओके, रूम के हाइट के बाद आपको सीलिंग दिख रहा है, सो ये जो सीलिंग है दैट इज ऑल्सो z इज इक्वल टू कॉन्स्टेंट. सो लेट अस से इट इज z इज इक्वल टू, लेट्स से इट इज 5 meters. सो 5 meter इज द 5 meter, और लेट्स से अभी तुम्हारा रूम जो है, ओके, सो तुम्हारा सपोज 50 meter आपका जो लेंथ है, सो 50 meter इज योर लेंथ ऑफ द रूम. Okay, so z is equal to 50 is your ceiling. It is also xy plane. It is parallel to your floor. So it is also xy plane. It is at a height of 50 meters. So it is a ceiling. Okay. So जैसे xy plane है वैसा ही दो planes और है. That is yz plane. yz plane में y और z है तो x नहीं है, तो उसको बोलते हैं x is equal to constant plane. So यहाँ पे x कोऑर्डिनेट जो, इसका मतलब क्या है, x इज इक्वल टू कांस्टेंट. फॉर एग्जांपल xy प्लेन, मतलब जो आप बैठे हो वो फ्लोर, तो इस फ्लोर पे आप कोई भी पॉइंट को इंडिकेट करो. यू टेक दिस पॉइंट और यू टेक दिस पॉइंट और यू टेक दिस पॉइंट. एनी पॉइंट ऑन द xy प्लेन विल हैव z कोऑर्डिनेट कांस्टेंट. सो आई कैन राइट डाउन 2 points on the xy plane जो आप फ्लोर पे बैठे हो. I can write down the 2 points as 5 2 5 0. ये एक पॉइंट हो गया. दूसरा पॉइंट मैं लिख सकती हूँ यहाँ पे 3 4, बट z कोऑर्डिनेट विल बी ऑलवेज 0. सो z जो है वो हमेशा 0 होता है when the plane is xy plane. ओके, सो xy प्लेन अगर आप बोलते हो तो उसका z वैल्यू हमेशा कांस्टेंट होता है. सो यू टेक एनी पॉइंट ऑन द xy प्लेन, देन इट्स z कोऑर्डिनेट विल बी ऑलवेज कांस्टेंट. सिमिलरली जो आपका सीलिंग है, सीलिंग में ये पॉइंट मैं क्या ले सकती हूँ 3 4 बट 50, बिकॉज उसका z वैल्यू क्या है 50. एंड z वैल्यू इन केस ऑफ z इज इक्वल टू कांस्टेंट प्लेन, द z ऑलवेज इंडिकेट्स द हाइट. Okay, because it is a height of your room. So you take any other value, any other point, 2 6, but z coordinate will be always 50. So xy plane में कोई भी दो पॉइंट्स आप इंडिकेट करोगे उसका z वैल्यू हमेशा कांस्टेंट रहता है. ओके, सिमिलरली और एक प्लेन रहेगा दैट इज yz प्लेन. सो yz प्लेन इज मेड अप ऑफ y axis and z axis. Okay, so इसलिए यहाँ पे as you can see here yz plane is basically has z and y as its edges. और इस पर्टिकुलर प्लेन में परपेंडिकुलर कौन जाता है x. सो हमेशा याद रखो जो कांस्टेंट होता है ना वो हमेशा, सो अगर मैं xy प्लेन बोलूंगी तो which axis will be perpendicular to its z axis. सो xy प्लेन को परपेंडिकुलर जाने वाला यूनिट वेक्टर क्या रहेगा, a bar z. इज इट पॉइंट क्लियर? इज दिस पॉइंट क्लियर? xy प्लेन का समझ में आ गया? ओके, सो xy प्लेन में परपेंडिकुलर वेक्टर कौन सा होगा, दैट इज अ यूनिट वेक्टर, दैट इज अ वेक्टर अलोंग z axis because z axis is perpendicular to xy plane, right? Similarly yz plane is also called as x is equal to constant plane. So yz plane में यूनिट वेक्टर कौन सा रहेगा, a bar x, that is the unit vector along x axis. Similarly जैसे दो xy प्लेन है आपका फ्लोर और सीलिंग, these are the two xy planes. Similarly there will be two yz planes. Similarly there will be two xz planes. So there will be 6 planes together. अगर आप ये 6 planes को complete करोगे you will get a cube. Is it clear to everyone? So ये 3 planes है, इसके पीछे भी 3 planes रहेंगे and you can here. Can you see here? Okay, so ये ऐसा क्यूब बनता है आपका. So there are 6 planes. Okay, 6 planes, 2 xy planes, 2 yz planes and 2 xz planes. So ये 6 प्लेन को मिलके आपका क्यूब बनता है. Okay, so xy प्लेन का मतलब है z is equal to constant plane, yz प्लेन मतलब x is equal to constant plane and xz plane means y is equal to constant plane. Okay, any doubts in this? अगर coordinates, अगर rectangular coordinate system समझ में आ गया तो cylindrical is on the same lines. Okay, so as I said, any point in the Cartesian coordinate system is the intersection of three planes. So when I say that, suppose when I say that the point is P, okay, suppose I write down a point P, which is 2, 3, 4, then what is this point? This point P is an intersection of x is equal to 2. This point is an intersection of x is equal to 2, y is equal to 3, and z is equal to 5. ये तीन planes जो है, x is equal to 2, y is equal to 3, and z is equal to 5. ये तीन planes को जो intersect करता है, देखो जब भी दो planes intersect करते हैं ना, okay? For example, I again take to this particular slide. Is this line visible? Is this slide visible?
Yes, ma'am. Yes.
तो जब भी ये दो planes intersect कर रहे हैं, जैसे xy plane, ये एक plane और ये एक plane एक दूसरे को जो intersect कर रहा है, तो what is intersection? Intersection is a line. ये intersect हो रहा है. लेकिन जब ये तीन प्लेन्स एक दूसरे को इंटरसेक्ट करते हैं, तो ये कौन सा प्लेन है? दिस इज z इज इक्वल टू 0. ओके, ये कौन सा है? z इज इक्वल टू 0. ये कौन सा प्लेन है? दिस इज xz प्लेन, मतलब ये है y इज इक्वल टू 0 प्लेन, और ये कौन सा प्लेन है? दिस इज yz प्लेन. सो दिस इज x इज इक्वल टू 0 प्लेन, x इज इक्वल टू 0 प्लेन. Okay, so intersection of x is equal to 0, y is equal to 0, and z is equal to 0 is your origin. ये मतलब ये तुम्हारा जो point है, this is your origin. So when I say that origin का मतलब क्या है? It is the intersection of three planes. This is x is equal to 0, y is equal to 0, z is equal to 0, right? So in the similar way, you take any points in the rectangular plane. It is the intersection of three planes. So when I say point x, y, z, that means it is the intersection of x is equal to x, y is equal to y, z is equal to z. Suppose you take any point 1, 2, 3. It is the intersection of x is equal to 1, y is equal to 2, and z is equal to 3. Okay, is this point clear to everyone? Okay. Now what I'm going to do is I'm going to increase. Okay, I'm going to increase this particular x, y, z. Suppose this coordinate. Okay, I locate any point x, y, z. X, y, z. Okay, अभी ये x, y, z को मैं differentially मतलब very small amount, minute amount से increase करूँगा. Okay, so I am going to increase this x by dx, dy, and dz. Okay, so this is one point. This is one point P. Then this will be another point, na? That is suppose P dash. See, any point is going to be is going to be indicated by its three coordinates. So P का coordinate क्या है? X, Y, Z. Similarly, P dash का point क्या है? अभी dash ऊपर होना चाहिए. P dash का क्या है? Coordinate X, Z, dx, dy, and dz. So अगर मैं ये P और P dash को connect करती हूँ, I have 2 points, right? I have 2 points here. So these are the three. This is basically one point, and this is another point, which is P dash. If I join these 2 points, then I'm going to get a line, and this line is going to be a differential line, और उसको मैं ऐसे लिखूंगी. ऐसे कैसे आ गया? आपने वेक्टर कैसे लिखा था? This differential line is P dash. तो वेक्टर कैसे लिखते हैं हम लोग? कोऑर्डिनेट ऑफ p डैश माइनस कोऑर्डिनेट ऑफ p. ओके, सो ये p डैश कैसे हो गया? डिफरेंशियल अमाउंट से मैं इंक्रीज कर रही हूँ, तो इसका एक्चुअली p डैश कैन बी रिटन एज x प्लस dx. आई एम इंक्रीजिंग दिस पर्टिकुलर पॉइंट, जैसे 1 को 2 कर दिया. Okay, so I can write down that as 1 plus 1, right? So similarly, suppose this is 1, then the p dash value will be written as x plus dx plus दूसरा है y plus dy. Okay, or third I can write down z plus dz. So I have increased this x, y, z with a differential amount dx, dy and dz. So x, y, z becomes x plus dx, y plus dy and z plus dz. Okay, for example, suppose p is 1 2 3 and p dash becomes 4 5 6. Okay, so I have increased 1 2 3 by some amount so that I get 4 5 6. Okay, so 1 becomes 4, so I have increased it by 1 plus 3, so this will be 1 plus 3. Okay, so pp dash is going to be, ये pp dash को वेक्टर को मैं कैसे लिखूंगी? This pp dash vector is going to be written as x plus dx minus x. Okay, so x cancel हो गया, इसलिए यहाँ पे सिर्फ dx बचा है. I am writing a vector. Okay, so vector कैसे लिखते हैं आप? Coordinates of p dash minus coordinates of p. So coordinate of p dash क्या है? x plus dx और coordinate of p क्या है? x. So x plus dx minus x becomes only dx. इसलिए यहाँ पे dx आया. Similarly, for y also it is dy and for z also it is dz. So differential line is basically a small line when you increase the coordinates by a small amount. Okay, so okay, so therefore the differential line in the coordinate system is written as pp dash, that is dx a bar x plus dy a bar y plus dz a bar z. So as you can see in this diagram, okay, as you can see in this diagram, this x y z basically are this p point. P point आपको कैसे मिल गया? P point is an intersection of 3 planes. Which are the 3 planes? X is equal to x, y is equal to y and z is equal to z. Similarly, p dash is another is an intersection of 3 surfaces. कौन से 3 surfaces? X is equal to x plus dx, y is equal to y plus dy and z is equal to z plus dz. So total मेरे पास कितने surfaces आ गए? 6. 3 p के लिए, 3 p dash के लिए. So इन तीनों को कनेक्ट करके मेरे पास ये ऐसा एक वॉल्यूम रेडी होता है जिसको बोलते हैं डिफरेंशियल वॉल्यूम. I hope it is clear to everyone. Okay, so suppose ये मेरा मोबाइल को 6 सरफेसेस है, 1 2 3 4 5 6. ओके, सो ये 6 सरफेसेस कैसे आ गए? सो इसके अंदर जो वॉल्यूम है, दैट पर्टिकुलर वॉल्यूम इज कॉल्ड एज अ डिफरेंशियल वॉल्यूम. और ये जो 6 सरफेसेस है 1 2 3 4 5 6, एक ये सरफेस, एक मेरे पास सरफेस, एक ये ऊपर का, एक नीचे का, एक लेफ्ट का, एक राइट का. सो देयर आर 6 सरफेसेस, टॉप, बॉटम, लेफ्ट, right, front and back. Am I clear? Am I clear, students? So there are 6 surfaces here, right? So हर एक surface को क्या बोलते हैं? Differential surface. Okay, so there will be 6 differential surfaces. एक होगा top, दूसरा रहेगा bottom. Okay, top and bottom. Suppose you take top and bottom. Okay, so bottom surface will be z is equal to 0. So this is z is equal to constant. Top surface will be z is equal to constant. जैसे आपका सीलिंग है ये सब कुछ top surface, और नीचे का जो है that is your floor. Okay, so whenever you say a cube consists of 6 surfaces. उसमें से 2 surface रहेंगे, z is equal to constant. 2 सरफेस रहेंगे, y is equal to constant. 2 सरफेस रहेंगे, z by x is equal to constant. So that's what is it is written here. There will be 6 differential surfaces. As you can see here, there will be 6 differential surfaces. Okay, 6 differential surfaces. 2 will be z is equal to constant, 2 will be y is equal to constant, 2 will be x is equal to constant. ओके, सो ये जो डिफरेंशियल सरफेस है, इनका एरिया कैसे लिखना है, इनका एरिया कैसे लिखना है वो मैं आपको समझा रही हूँ. तो सपोज ये एक टॉप सरफेस है और ये बॉटम सरफेस है, दोनों भी सरफेस कौन से हैं, z इज इक्वल टू कॉन्स्टेंट. इसका मतलब क्या है, ये जो एज है एक x है और दूसरा y है. एम आई क्लियर? दिस इज xy सरफेस and that is why it is z is equal to constant surface. तो इसका जो परपेंडिकुलर रहेगा that is my z axis. So this is x and this is y and this is my z axis. Can you see my ring finger? All of you look at the video. Look at my video. This is x. This is y. These are the two edges of the plane xy plane and the perpendicular edge is going to be z axis. तो अगर मुझे इस xy z का xy प्लेन का ये लिखना है, एरिया लिखना है, तो मैं कैसे लिखूंगी, dx into dy, dx into dy, dx into dy करूंगी तो क्या होगा, dx is this distance, dy is this distance. तो आप एरिया कैसे निकालते हो, dx length into breadth. So dx into dy will be my magnitude of the area of xy plane और z is equal to constant plane. So इसलिए यहाँ पे लिखा है, देखो z is equal to constant plane जो है उसका एरिया कैसे लिखा है, देखो dx into dy. So dx and dy because z is equal to constant plane, ये कौन सा प्लेन है, ये है बेसिकली xy प्लेन. So इसका जो लेंथ that is dx into dy. Please remember, whenever you are calculating the area of the differential surfaces, it is going to be a vector. It's going to be a vector. तो इसका मैग्नीट्यूड क्या होगा, अगर ये xy प्लेन है तो मैग्नीट्यूड विल बी dx into dy और इसका डायरेक्शन कौन सा होगा, इसका डायरेक्शन होगा जो भी एक्सिस इस पर्टिकुलर प्लेन में परपेंडिकुलर है. तो अगर ये xy प्लेन है तो परपेंडिकुलर एक्सिस कौन सा है, z. इसलिए यहाँ पे इसका जो डायरेक्शन लिखा है वो a बार z लिखा है. सो यू टेक एनी सरफेस, सपोज द सरफेस इज xz प्लेन, तो इसका मैग्नीट्यूड में कैसे लिखूंगी, dx into dy और इसका डायरेक्शन क्या होगा, डायरेक्शन will be given by unit vector which is perpendicular to it. तो अगर xz प्लेन है तो उसमें कौन सा एक्सिस परपेंडिकुलर होगा, y, और y के अलावा कौन सा यूनिट वेक्टर होता है, a बार y. इसलिए यहाँ पे लिखा है dx dz और यहाँ पे लिखा है a बार y. अगर आपका सरफेस x is equal to constant है, x is equal to constant मतलब ये सरफेस कौन सा हो गया, yz, right? I know I'm exceeding the time but this is the last slide. Okay, so yz प्लेन अगर है तो इसका एरिया मैं कैसे लिखूंगी, dy into dz और इसका यूनिट वेक्टर कौन सा आएगा, the axis which is perpendicular to it. तो कौन सा एक्सिस इसको परपेंडिकुलर होगा, x axis, और which unit vector is along the x axis, a bar x. So this is how you write down the differential area of the 6 differential surfaces. और differential volume का रहेगा, volume will be a volume doesn't have any vector. Vector कौन सा होता है, differential length is a vector, differential line is a vector, or differential area, differential surface area is also a vector. इसलिए line में भी unit vector आया है और डिफरेंशियल सरफेस एलिमेंट में भी आपने यूनिट वेक्टर लिखा है, लेकिन जो वॉल्यूम है, वॉल्यूम इज नॉट अ वेक्टर. सो वॉल्यूम कैसे लिखेंगे, इसका लेंथ क्या है, dx, व्हाट इज अ ब्रेड्थ, dy और हाइट क्या है, dz. सो dz dx dy dz ये जो मल्टीप्लाई होगा, ओके, सो दैट विल बी द डिफरेंशियल वॉल्यूम, दैट इज द वॉल्यूम व्हिच इज inside these 6 surfaces. Okay, So this is how you calculate the differential line. If you write down the differential line, तो इसका जो formula है ना, ये formula आपको याद रखना है. Maybe it is useful in when we will solve the problems in the first chapter. Okay, so I think if rectangular coordinates are understood, then the next is cylindrical coordinates. That will be more easy for all of you to understand in the next in our next lecture. Okay, so is rectangular coordinates clear to